All right, Unit 1, Lesson 3, Midpoint and Distance Formulas. There's a couple ways that we can do this, and so let's go ahead and get started. So right here is your midpoint formula. Notice you have your x's and your y's. So again, just a reminder, the x is the number on the left in a parenthesis, the y is the number on the right. And again, you see that we have x1 and x2, y1 and y2. That's because we have different, you might have like 2 and 4. This could be x1, y1, and then you have to have a second point. So maybe you say it's 6 and 10, and that would be x2, y2. So again, the ones and the twos are corresponding to, you need at least 2 different points to find the middle. So we'll do an example. So right here, we've got our point S, which is 4, 2, and we've got our point R, which is 1, negative 3, and we need to find M. So my formula, x1 plus x2 divided by 2, and y1 plus y2, divided by 2. Again, how do you find the middle? You add them up and you divide it by 2. So I'm going to call S my x1, y1, and I'm going to call R my x2, y2. So I'm going to take 4 x1 plus x2, which is 1, divided by 2. I'm going to do all my work first. I'm going to show all my work, and then I'm going to simplify it later. And then y, my y1 is 2, and my x, or my y2 is negative 3. So 4 plus 1 is 5, 5 over 2. 2 plus negative 3 is negative 1 over 2. So if we look, this would be 5.5, or if I wanted to write it as a fraction, 2.5 and negative 0.5. So, and if we look right here, that actually looks exactly where it is. 1, 2, it's in between 2 and 3, 2.5. And this would be negative 1. So it's in between 0 and negative 1, which is how we get 2.5 and negative 0.5. I want to show you one other technique to solve this. It's the table method. So we're going to put x's here, we're going to put y's here. All right, so my starting point, I'm going to say is R again, which is 4 and 2. And my ending point, so I'm going to start here, I'm going to end here. My ending point is 1, negative 3. So I got to figure out, hey, if I'm finding the middle, I need to go 1, 2. So this is a difference of total from 2 to negative 3. This is a difference of 5. Okay, so I'm subtracting 5, but I only want to subtract half of that. Again, I need to have equal jumps. So if I have equal jumps, that's going to be subtract 2.5 and subtract 2.5. So 2 minus 2.5 is negative 0.5. Negative 0.5 minus 2.5 is negative 3. Over here, I go from 4 to 1. Okay, so that's a difference of subtracting 3. But if I need to do equal jumps, if I have a total of subtracting 3, that means I need to subtract 1.5 each time. So 4 minus 1.5 is 2.5. 2.5 minus 1.5 is 1. And you'll notice we get the exact same answer, 2.5 and negative 0.5. Okay, I personally, again, there's not one way better than the other. If you want to use the formula method, if you want to use the table method, I kind of like the table method myself. So let's call it x and y. So my starting point is 1 and 4. I know that the middle is going to have something. Oh, so this is why, again, this is why we like using the table method, because notice I'm not given my endpoint. I'm given the midpoint. So I can plug this midpoint in here, and this is going to be 2 and 1. And this is what I need to figure out. I need to figure out what is this endpoint over here. So what is this area right here? So let's do some of our jumps. So from 1 to 2, I add 1. So if I need to do the exact same thing here, 2 plus 1 is 3. On the left, or on the y coordinates, 4 to 1 is subtracting 3. So if I need to make that same exact jump, again, to find the middle, I know that I'm going to get 1 subtract 3 is negative 2. So my final coordinates for x is going to be 3, negative 2. And if we look, that's exactly what it looks like. 1, 2, 3, and down 1, 2. And we also have a distance formula, okay? So it's kind of similar to find the distance formula, okay? So again, right here, this is something that you're gonna wanna remember, you're gonna wanna write down, okay? x2 subtract x1 and square it, plus y2 minus y1 and square it. And then you're gonna add all those together and then subtract then you're going to take the square root of that number. Okay, and again, you can kind of see like, why does this work? Because again, what we're doing is we are building a right triangle. And again, geometry, we use triangles all the time. So you'll notice this gives us the distance of our x coordinates. This gives us the distance of our y coordinates. And what we are actually finding, the total distance, is right here. We're trying to figure out how far this line is. So let's do an example. First things first is I gotta label my x1 and my y1. X1, y1. Does it matter which one you pick? No, but you have to be consistent. So if this point right here is x1, it also has to be y1. I can't call this x1 and y2. Okay, you have to be consistent with your points. So the distance of RS equals, underneath our square root, maybe get a different color. Let's use our x, let's subtract our x's. So x2 minus x1, 4, subtract 2 and square it. Plus, and I'm gonna get my other coordinates, my y's, y2, negative 1, subtract 3 and square it. Okay, again, always write out your equation first and then you can solve it later. So let's start simplifying. 4 subtract 2 is 2, and we still have a squared on top, plus negative 1 subtract 3. Remember, when you subtract a number from a negative number, it's like adding the opposite. So negative 1 take away 3 is actually negative 4. 2 squared, 2 times 2 is 4. 4 squared, 4 times 4, so excuse me, negative 4 squared. Negative 4 times negative 4 is positive 16. So we're almost done. 4 plus 16 is 20. Now, I can simplify this again. Think about our review lessons from last week. You have to simplify this. So let's do some side work. What numbers multiply to get 20? 1 and 20. 2, 10, 4, 5. Do we have any perfect square numbers? Yes, we do. 4 and 4 times 5. So let's rewrite this problem as the square root of 4 times 5. I can split these up. The square root of 4 times the square root of 5. And the square root of 4 is 2. Square roots of 5. Because it's a distance, I know it's not negative 2, right? Distances aren't negative. So 2 square root 5 is the distance from R to S. The distance from R to S. What is the exact length of AB? With endpoints being A, negative 3, 2, x1, y1, and B, being 1, negative 4, x2, y2. So let's use our formula. AB equals the square root. X2 is 1. X1 is negative 3. 1 subtract 3. Ooh, that's kind of, I had too much coffee. My hand is shaking. 1 subtract negative 3. Don't forget to square it, Mr. Larson. Ugh. Plus y2, negative 4, subtract y1, 2, and square it. Okay, let's start simplifying. If I'm simplifying, AB equals the square root. 1 subtract negative 3. Remember, when you subtract a negative number, okay, like this, these negatives cancel out. And so it turns into a super, I call it a super addition sign, a super plus. Okay, so 1 plus 3 is this. So 1 subtract negative 3 is the same as 1 plus 3, which gives us 4. Plus negative 4 subtract 2. Again, negative 4 take away 2 is like adding the opposite. So negative 4 plus negative 2 is negative 6 squared. So let's simplify. 4 squared is 16 plus negative 6 squared. Negative 6 times negative 6 is positive 36. 36 plus 16, 2, 4, 5, 52. Okay, so equals the square root of 52. And now I got to think about what are all my numbers that I can multiply to get 52. All right, we always know that we have 1 times 52, right? That's always a good starting point. 1 times 52, it's an even number, so I know that 2 times 31. Let's see, does 3 go into it? 52 divided, nope, that's not even. 52 divided by 4. 4 and 13 go into it. So I know that 4 is a perfect square, so we can at least simplify it a little bit. Let's think, 5, no, 6, no, 7, no, 8, no, 9, no, 10, 11, 12. Okay, so we don't really have any other numbers that match, which is fine because, again, we have a perfect square. So let's rewrite this as equals the square root of 4 times the square root of 13. And the square root of 4 is 2 square root 13. 13 is a prime number, so we know we can't simplify that any further.